Hey guys, so today we're going to be running through another threat hunt scenario. I actually already ran through this and have this written up in a document on my GitHub, but I wanted to run through this in a video to show step by step what the process is. I'm actually not going to be building any of the KQL queries live here in this video because I already have this done. So I'm just going to be copying and pasting my already existing KQL queries that I used and just explaining them as I'm using them. So the scenario here is that an employee named John is working in a sensitive department, recently got put on a PIP, performance improvement plan. And afterwards, management raised concerns that John might be planning to steal information. So the task here is to investigate John's activities and take a look using MDE to ensure nothing suspicious is taking place. For the sake of this lab, again, I'm going to be focusing on my personal virtual machine that's hosted in this environment. So what I did to start this is use device file events where device name equals king because, or contains king because this is my virtual machine that I'm going to be inspecting, and sort the action type as file created. And it's going to be a zip file because he's going to be extracting data. So we're going to be looking for zip files, and we're going to order this by timestamp descending. And I'm setting this to the past 7 days because I did this write up a few days ago. I just didn't make a video about it. So I need a broader time span here. But you can see that there is a file created on the day that I have this written up, and it is employee data. If I click this to open it, you can see employee data.zip was created in this path, and it was actually done so via command line, which then opened up a PowerShell, which then executed the command appropriately. So we can see that the file was created at this particular time um, and renamed to a zip file and then moved to the location of employee backup, which you see right here, backup folder. There's the folder path. Employee data in C program data backup. Okay. So in this instance, he took a zip file and put it into this backup folder. So what I did was took the timestamp and outlined a query to search for other related events near the specific time range to discover the following. So again, I already have this done. I'm just copying and pasting things that I have already done, and I'm just going to explain it here. So here, I've defined a variable for the device in question, which, let pip device equal this device, and the specific time equal the time frame outlined for when this happened. And we're going to put both of these variables into the device process events table, where the timestamp is between the specified time, which is right here, plus and minus 5 minutes, and search for the device name, again outlined here, where the account name is associated with the user in question. And we're going to order the output by a descending timestamp and project the timestamp, the name of the device, the action type, the file name, and the process command line, which started the extraction. And here we can see the device, and we can see 7zip.exe. Here we can actually see PowerShell then running this 7-zip, I guess this is a version number, 2408, being called as an exe, and then like to install, install /s, so this is a silent install, and then 7-zip running to actually zip the file. So let's see if we can get a better process tree. PowerShell. Maybe it's here. Okay, so in any case, what we can see is that within this specified time, PowerShell was run and called a silent install of 7-zip, and then 7-zip was used to output employee data into the program data folder. You can see here if I just hover over it. So it does actually seem like this guy's doing something a little suspicious. It's up to no good. So all right, he created the zip file and tried to extract data, right? Well, let's take a look to see if any outbound connections were made where he put the specified information. So I already have that KQL query, and we're going to explain this again. Again, creating a variable for the same device, and this time we're checking the device network events table. And here we're going to be checking for the device name that's being outlined in the variable up here, where action type contains outbound connection. So it's trying to see what connections from this device are going out and order it by timestamp descending. We're going to keep this to 7 days because, again, I did this right up on the 13th. Today's the 16th, and we're going to see what we get. Nothing. So it's kind of safe to assume in this instance that John, who is using this machine, did create this backup directory with all of the pertinent information and did not make any outbound connections to actually send the information anywhere. That doesn't necessarily mean much. He could have put in a USB, like a thumb drive, and just put everything that he extracted from the backup folder onto that thumb drive. But nonetheless, you can see that no outbound network connections were made. But we did see, using this and this as well, that this was all done via command line calling PowerShell to run, right? PowerShell is being run here. So there was a script or a series of inputs put into PowerShell to issue this, and based off the timestamp, it's kind of safe to assume that this was a script that was run. So using remote access RMM, you can actually extract the script. I have the script posted inside of my write-up of the scenario, but here I will actually copy it and I'll paste it right here. This is the script in question. So it's defining the log file path here and the script name, exfiltrated data. It is then defining up more variables for log entries and timestamps, and it is getting the employee data and putting it inside of the CSV. So we can, from this, infer that the user was actually attempting to do something malicious by exfiltrating company data, and consequently, we need to act on this. So the first action would be to go over to the device and isolate the device from the network so that no outbound connections can be made. And then his supervisor should be contacted immediately and let them know of what this user is doing on his device. I'm just going to go ahead and drag over a section of my report so I can show you the TTPs used in this attack. We can see initial access. Script was executed by this user. Um, Execution, attacker used PowerShell to silently install 7-zip. The script appears to have been running at regular intervals. This is true because it's running in the background because this is a lab-based environment, but for this particular instance, we can kind of strike this because this is supposed to be an isolated instance. The attacker renamed and moved the files to evade detection, possibly. This is also true. Files were moved to this backup to conceal exfiltrated data. Attacker used PowerShell for credential theft. This does not entirely seem accurate. I'm going to strike this from my report. Script accessed and modified employee data files, which is accurate, suggesting an internal reconnaissance step. PowerShell commands were used to disable logging and check for security tools. This technique applies. This does not apply because no logs were disabled. Employee data was first saved to a CSV, then compressed into a zip file, which is true. This is a collection. Attacker used 7-zip to compress files. Script attempted to upload the zip file to Azure Blob, which is true. This is what is inside the script. Oh. Maybe I can't search in here. Upload, maybe? Upload. I can't find the specific line. Where's the out path? It actually does not. Okay, so this script is actually supposed to include an outbound connection to an Azure Blob storage, but it doesn't exist. So this can also be stricken. No, this can be stricken. And this is also true. So data destruction is true because he's taking the data and changing the file and sending it out. And well, not really sending it out in this instance. What he's doing is potentially exfiltrating on like a thumb drive or something like this. So our response in this scenario would be to isolate the machine, disable admin access on machines to prevent potentially malicious scripts for being executed and unwanted applications from downloading without approval, and set alerts for suspicious PowerShell execution. For our improvement, we could set up a defender for endpoint alert to detect PowerShell scripts containing 7-zip and or invoke web request. Correlate PowerShell execution with network activity to detect exfiltration and restrict PowerShell execution policy to signed scripts only. All right, guys, thank you so much for joining on this particular threat hunt. See you in the next one.